Hello, this is Chuck Winkelmann proving problem 3 on homework M5. Problem reads, let C be the set of all infinite sequences, each of whose entries is a digit 0 or the digit 1. Is the set C a countable set or an uncountable set? Prove your conclusion. I'm going to conclude that C is an uncountable set, so I'm going to prove this by contradiction. And I'm going to assume C is countable. Because I assume C is countable, that means I can make a list of all sequences. So sequence 1 is going to be A11, A12, A13, so on. Sequence 2 is going to be A21, A22, A23, and so on. Sequence 3 is going to be A31, A32, and A33, and so on. And we have more sequences, and each row is an infinite sequence of zeros and ones. So from here, we're going to build a new sequence by diagonalization. And we're going to call it D, containing D1, D2, D3, and so on. And we have each of these elements, Dn, determined by if ANN equals 0, it's going to be 1, and if it's going to be 0 if ANN equals 1. And this is defined by flipping the diagonal entries of our list. So we have these diagonal entries, and it'd be A44, A55, and so on. So say we wanted to determine D2, we'd go up here and select this and say it's 1. So we'll determine that D2 is the opposite of A22, so it's going to equal 0. And from there, we can determine that D is going to differ from every single sequence in the list in at least one place. So D differs from S1 in the first digit because we took this digit and flipped it. S2, we took this digit, and so on, and we flipped them all. So D differs from every sequence in at least one place. But earlier we assumed that we had every sequence listed here. We had every sequence in C, but we determined that D differs from each sequence, so D is not in the list of sequences S1, S2, S3, etc. And so that brings up a contradiction. Which means our previous assumption that C is countable must be false, and therefore C is uncountable. And then we can read this out in a formal proof. Assume for contradiction that C is countable, then we can list all elements of C as a sequence. S1, S2, S3, where each Sn is an infinite binary sequence, AN1, AN2, AN3, with ANK being in the list 0, 1. We now construct a new sequence by diagonalization, where each element is flipped depending on their position. So for each n, we flip the nth digit of the nth sequence. And by construction, D differs from sequence 1 at position 1, from sequence 2 at position 2, and 3 at position 3, and so on, which brings a contradiction. Therefore, D cannot be equal to any Sn on the list, as it disagrees at least at the nth position. But D itself is an infinite binary sequence, so it should be on the list if the lists were complete. So this contradiction shows that no list can capture all sequences. Therefore, our assumption that C is countable must be false. Thus, C is uncountable. And that's that.